Okay, so what we will be discussing today is something short, and that is the XGBoost model in Python. So here we won't follow the approach we usually follow. So we will just go through this content as already you guys know how to fit machine learning models. Yeah, so let's go through the theory part that is here first. So I've shared the link in the chat section. So if you don't have it, I'm going to reshare again. Yeah, so over here we have XGBoost. So XGBoost is one of the most popular machine learning algorithms these days, regardless of the type of prediction, task at hand, regression or classification. So XGBoost is tree-based. So this means it can fit both regression and classification tasks. So XGBoost is well known to provide better solutions than other machine learning algorithms. So in fact, since its inception, it has become the state-of-the-art machine learning algorithm to deal with structured data. So, but what makes XGBoost so much popular? So its speed and performance. So it was originally written in C++, and C++ is a little bit faster as compared to Python, and this is, yeah. Then core algorithm is parallelizable, so it means you can use GPUs instead of just using CPUs, because GPUs are more faster than CPUs. So if we click on runtime here on Colab and click on manage sessions or runtime, change runtime type, you can choose a GPU or a TPU. But I see here that GPUs are premium. So here we have the T4 GPU. And if we check, for example, the T4 gives you the premium GPUs give you additional compute units. So it means that GPUs are more preferred as compared to CPUs. And that's where the advantage of XGBoost models come in. So they allow you to leverage the power of GPUs. So they consistently outperform other algorithmic methods. So the scores that you get for using XGBoost are kind of better as compared to those that you will do using the normal models like the linear regression and the logistic regression. So those models that we've been discussing in class. Then it has a wide variety of tuning parameters. So XGBoost internally has parameters for cross-validation, regularization, user-defined objective function, missing values, tree parameters, and sklearn compatible APIs. So you need to research more on this to understand which one can you use and which one can you not use. So we will start. So before you understand how XGBoost works, we will start by understanding what boosting is. And from the theory that we have here, we can see that boosting is a sequential technique which works on the principle of an ensemble. So it combines a set of weak learners and delivers improved prediction accuracy at any instant t. The model outcomes are weighed based on the outcomes of the previous outcome t minus 1. The outcomes predicted correctly are given a lower weight, and the ones misclassified are weighted higher. So for example, if we check this diagram, we can see D1, which is our box 1. So you can see for box 1, we have these two plus signs that have correctly been classified to be positive classes. So maybe I can draw this for you elsewhere so that you can understand it better how it works. So for example, if we are fitting a model, so we can have this as our first model. So I'll say this is model 1, okay? For model 1, we have these classes. So what the model will do is it will fit. So let me draw these boxes again, and we'll just assume they are hidden. So here we have model 2, and then we have model 3. So for model 1, we have this class over here where we know we've correctly predicted the positive classes and we have no instances of negative classes being predicted. Then I'll go to model 3 where I know I'll fit this upper part and I'll predict them correctly to be positive classes. And then again here, I will go up to this part here where I know I will have a mixture. So when I am to combine these three models, so if I combine them and come up with a single model, then this is what I'll come up with. So I'll know that for this line and this line, I have correct classes. So that is the positive classes. And then for this box that is down here where I don't have a line, I will know that these should be my negative classes. And these will be our model 4. And model 4 is a combination of model 1, 2, 3, giving you better accuracies. So that's how XGBoost works. So we can go through here, this theory here, and see how it's explained. So box 1, the first classifier, usually a decision stamp, creates a vertical line split at D1. So this is where D1 is. So that's the vertical split that we have there at D1. So it says anything to the left of D1 is positive and anything to the right of D1 is negative. However, this classifier misclassifies 3 points. So anything to the left of D1 is positive and anything to the right is negative. So that's how this model initially works. Then we have box 2. So the second classifier gives more weight to the 3 misclassified points and creates a vertical line at D2. Again, it says anything to the right of D2 is negative and anything to the left is positive. So still it makes mistakes by classifying 3 points incorrectly. So here you can see we have these 2 negative points where we can say anything to the left, to the right is negative, anything to the left is positive. Then we have D3. Again, the third classifier gives more weight to the 3 misclassified points and creates a horizontal line at D3. Still, this classifier fails to classify all the points correctly. So here you can see anything to the upper side can be said to be positive and anything to the lower side can be said to be negative. But still, we have instances where we misclassify. So what we usually do is we get box 4, which is the weighted combination of the weak classifiers, box 1, 2, and 3. And as you can see, the accuracy that we get for this single box that we have here turns out to be better than actually what we have in the main model. In the small categories of models that we have. Yeah. So the basic idea behind boosting algorithms is to build weak models and making conclusions about the various features, importance, and parameters, and then using those conclusions to build a new, stronger model and capitalize on the misclassification error of the previous model and try to reduce it. So that's our main aim. So now let's come see XGBoost. So XGBoost is a tree-based model. So it combines different decision trees to come up with a single tree that has better accuracy. So how do we fit XGBoost? So I will skip the data importation part and then we will go to the model fitting part, which is the most important part. So what we usually do is we import XGBoost from XGB. So you can see it's a standalone model by its own. So it's not dependent of sklearn. Then we have from sklearn.metrics import mean squared error. So we use the mean squared error to evaluate our model. Then we can import pandas and we can also import NumPy. Then we separate our data into features and target. Then we create a data matrix. So XGBoost is mostly reliant on data matrix, as data matrix are fast as compared to the normal pandas or arrays. So here you can see, now you will convert the data set into an optimized data structure called a D matrix that XGBoost supports and gives it acclaimed performance and efficiency gains. Okay, so we will have our data underscore D matrix being equal to XGB dot D matrix. Okay, and then we will have our data being equal to X and our label being equal to Y. So this is just like specifying what the features are in your data set and what the target are. Then we have XGBoost hyperparameters. So you can go through these on your own free time as we've discussed some of them. So for example, the learning rate, the number of estimators. So the number of estimators is the number of trees you want to build. Okay. Then we have some regularization parameters that we have here. So for example, when we were learning regression using linear regression, so we saw that we had the ridge and the lasso regression models that we can fit. Then we split our data into training and test set. Then we fit the XGBoost model. So we have this as our regression task. So XGReg being equal to XGB dot XGB regressor. Then we specify the objective. So here where we are specifying the objective, so the model will get to know if we are fitting a classification task or a regression task. And because the objective is reg and we are using the squared error to monitor our model, so this model that will be fitted here will be a regression model. Then we have call sample, learning rate, max depth, alpha, and the number of estimators that have been defined here. And after instantiating the model with all those parameters, we go ahead and feed this to our training data and predict on our text set. And then we can score our model. So scoring the model, we get a score of 0.1935, which is not that good. So you can go ahead and compare that with other models. So for example, the random forest, and see it having a better score of 0.49. So the reason as to why we are getting this lower score is because we have to fine tune these hyperparameters that are in here to optimize the model to give a better score. So you can work on that. So that's where the k-fold cross-validation part comes in. So what we do is we create a parameters grid. So already we've covered hyperparameter tuning and cross-validation, whereby we create a list of parameters, and then from those parameters we train our model, and the model outputs different results for each and every fit. And you can see if we print the best model score, we get 0.59 as the best model score, while random forest up here had 0.49. So you can see that's an improvement as compared to what we had here at 0.19. So you can see how hyperparameter tuning at times help in data tuning. Okay. And then one last thing you can do is you can visualize your XGBoost tree model. And this is an example of what we get. So it's just like a decision tree, but the appearance here is different. So I won't go deep into this. So I've shared the resource, so I'll give you time to go deep into it, and maybe you can share questions if you have any. So yeah, what we can do is for tomorrow, I'll try share a notebook, so another notebook that you can use to practice fitting XGBoost models and try and understand them better. So yeah, that's it for me for now, not unless you have questions.